Hi everyone, it's Mrs. Summer here to talk about lesson 702, linear versus exponential functions. So recall from the beginning of this quarter and all of last quarter that a linear function, we are using, this is the slope-intercept form, and it's y equals mx plus b, where m is your slope, b is your y-intercept, and y is point on graph, and x is equal to a point on the graph. And your linear function looks like a line, hence the word linear. Well, now we're going to talk about exponential functions. So an exponential function kind of looks like a really cool slide. And the general equation for exponential function is y is equal to a times b to the x power, where a is your starting amount, how much you start off on day one. B is the multiplier, how much is your money or this growth being multiplied by. X or y is your output value, and x is your input value. So typically, x is a time function, so how many days that you're going to be applying the multiplier to your starting amount. And it looks like this really cool graph. So on this, it says to classify each function as either linear or exponential. So this one here is going to be linear. We have it looks like the slope-intercept form. 3x plus 1. So anytime you see it's 3x and then you're adding some value, it is a linear equation. This one here, the next one, is an exponential function because you have some number, your starting amount, times your multiplier of 3 to the 5th power. This next one is also exponential because you have y is equal to 5, which is your starting amount. 4 is your multiplier. And 3 is your input value. Okay? This next equation here, or graph here, is linear. It looks like a line, so it's linear. This one looks like a really cool slide, so it's exponential. Now, this one is kind of tricky because it's in standard form of an equation. But even though you rearrange it, you're still going to have an addition or subtraction part. So this is going to be linear. So you try. Classify. This will be A, B, C, D, E, and F. So with the Edpuzzle questions, you're going to answer the whether these equations are exponential or linear. Okay, so as for this, the first one is exponential. The second, B is linear. C is linear. D is exponential because it looks like a really fun slide. And E is linear because it's a line. And then F is linear. It's in standard form of a linear equation. So here's a word problem. John and Jordan are studying population growth in their science class. Each student in the class gets to choose a type of insect to raise for 4 weeks. John decides to raise fruit flies, and Jordan decides to raise fire ants. They both start with 20 insects. They count and record the population each week. Look at the data they collected and analyze the situation further. So if we look at John's fruit flies, we see that on week 0, he started with 20. Week 1, he ended up with 40. And week 2, he had 60. So what did we do here? We added 20. So to write the next equation, we would probably be 80 on week 3, 100 on week 4, and 120 on week 5. The equation, if we were to write equation from this, would be, this is our y-intercept, So we would have y, and our slope would be 20, 20x plus 20. For Jordan's, we see that she starts with 20, then it goes to 40, which looks very similar to John's, but then you can see the difference. So we added 20, and then this increased by 40. So 20, you doubled it here, and then here you had to multiply 40 by 2 to get 80. So for week 3, I'm going to multiply by 2. So I'm going to rewrite this as times 2 times 2. So then 80 times 2 is 160. 160 times 2 is 320. And 320 times 2 is 640. If we were going to write this as an exponential equation, we would write it as y is equal to our starting amount, which was 20. What did we do? What was our multiplier? Our multiplier was 2. And then to the x power, because we don't know how many weeks. We can calculate on week 10 by putting in 10 for x. We get y equals 20 times 2 to the 10th power, and we can get the number of fire ants at 10 weeks. So we kind of already answered these questions, but how does the total number of fruit flies change each week? You add 20 each week. Okay, and then how does the total number of fire ants change each week? It doubles. What type of functions were modeled by the fruit fly? Linear. And what type of function was modeled by the fire ant? Data, exponential. So you try. The school is trying to support the school band. The principal of the school is offering to pay students that will work at the school over the summer. He gives the students the following options for their pay. Option 1, the student will receive $10 on the first day, and then $5 each day each following day. Option 2 is the student will receive $1 on the first day, and then it will double each following day. So first you need to fill in the table with the correct amounts. So I'm going to write A, D, E, so on day 1, for option 1, the student would receive $10. And then they would receive $5 on day 15 on day 2. And then they're going to add $5 to get 20, 25, 30. So then option 2, though, they start with $1, but then it doubles. So here we added 5 each time. Over here, we're going to multiply by 2 each time. So then what type of function represents the data in option 1? It's linear because the amount increases by a constant amount. Exponential for option 2 because it doubles each day. So how many days must a student work to make $50 under each option? So under option 1, they have to work 9 days. And option 2, 7 days. So let's look at those equations. So for option 1, their starting amount would be $10. That's your y-intercept. Plus additional $5 a day equals their total amount that they've earned. Option 2 is that they start with $1 on day 1, but the amount doubles and to however many days that they work. So if we're going to put 50 in for here, we have 5x plus 10. Then we get 40 equals 5x. X is equal to 8. And this answer key is wrong because it should be 8 days for for option 1. So option 2, we can just start plugging in numbers. We have 50 is equal to 1 times 2 to the x. And so if I plug in 3, I'm going to plug in 50 is equal to 1 times 2 to the third. Well, 2 to the third power is 2 times 2 is 4 times another 2 is 8. So it would be only $8. Then let's try a different value for x. We can try 50 is equal to 1 times 2 to the 6th. We get, and then 50 is equal to 1 times 2 to the 6th power. 2 to the 6th power is 64. So this is more, and so it's actually going to be 6 days.